All right. Hey, everybody. So we are at week 4. So this is the last week of class. I have had a lot of fun with this class. I hope you have too. Um, and so a couple just like sort of housekeeping things before we get started. So we had our our very first co-working session on Friday. James and Diego came in and hung out, and I learned a lot from that session. I'll talk a little bit about what we learned in just a minute, but I'll try to do these for at least the next couple weeks. So if anyone is sort of like catching up or just like still playing with stuff, we'll do more sessions so people can join and ask questions and we can work through some things. I didn't get to it yet, but I will this week, hopefully this weekend. I will post a poll just to sort of see a time that would be good for everyone to sort of do like a show and tell. As a reminder, those show and tells are meant to be very low key, just sort of like show a couple things you worked on. It does not have to be anything fancy. It can be stuff you got stuck on. It can be stuff you enjoyed playing with. Like it doesn't really matter. So I just find that those are fun sort of end of class things to do just to sort of like keep everyone motivated through, a little bit after the class to make some stuff. Those are usually about 2 or 3 weeks after this class. So I'll just post some times and have people vote on it and we'll pick whatever is the democratically like best time for people. And if you can't make the session or if you're just like not a public speaker type, you can go ahead and record a video and I can play that as a part of the show and tell as well. So I'll post that this week. I will also post a feedback form. So if you have feedback for this class, especially since this was the very first class of this type of material that I've taught, I'm very open to feedback. I think we've changed this sort of the schedule a lot or like sort of modified things as is. But I'm sure we missed some stuff and think we probably could have played more in local command line versus Colab. I think there's lots of things we could be doing for future classes. So I'll post a quick feedback. I do always take that feedback very seriously. So feel free to be as critical as you want to be, because I do want to make the next session of this, if we do another one, better than the first. So I really appreciate people's feedback and will always take criticism well. It's never held against you. And I believe you can file it anonymously. So if you, but if for whatever reason don't want to put your name on it, that's totally fine. So I'll share that this week as well in our Slack channel. Yeah, so with that, I think we can get started with today's session. I wanted to see, so I know, I think James, I think you put a couple things in the Slack channel this week. Is that right?
Yeah, two slit scan pieces. One was, should I just talk about them?
Yeah, talk about them. I'll pull them up on my screen real quick.
Okay.
But yeah, go for it.
Yeah, first one, well, both of them are simple slit scan pieces. The one you had discussed in class was horizontal scripts. I did vertical scripts instead. The only little thing I did for this piece, the source materials from Wong Kar-wai's Chunky Up in the Mood for Love. The only thing I did was I tried doing an H flip for each strip. So like the faces and such, like you can still form them and recognize them, but they're actually being flipped. You look at each strip, just for some visual variety.
Cool.
Then the second one is from a time-lapse video, the source material done by a gentleman named Eric Solheim, I believe, and he's done these timeless videos where he leaves the camera at, I suppose a backyard or something for the entire year, taking snapshots and videos, and makes these long time-lapse videos. And then so I did the slit skin effect, so the seasons seem to travel from one direction to the next. Yeah, and yeah, I want to play with this type of source material more because I think, yeah, you could generate a lot of cool little videos out of time-lapse material. Unfortunately, they don't loop perfectly. So, yeah.
You know what's so funny is I only ever viewed this video at this scale, and I thought you were doing some sort of blur effect on the strips. It's only when I looked at it at full size that I was like, oh, those are just the little strips. So it's really interesting how even scale affects, how you sort of see these things. Because I was like, oh man, that's a really cool like sort of like blurring effect, but it's actually because of the slit scan that you get that. So that's really cool. I like that.
Right. Yeah, I played with the width of the strips and the offsets a little bit. I spent like half an hour playing with different
Mhm.
values because they do give you like you can make it much more subtle or make it much more explicit that there are offsets happening. Yeah.
Yeah, no, I mean that's sort of the fun about this stuff, right? Is you could spend a whole day tweaking little variables here and there and get like dramatically different effects. It's great. Um, Will, I think Will might still be driving, but I think he also posted that sort of the one that was more of the blocks from the center. And I love the effect of this. It has that like very light trailsy sort of thing.
Yeah, I'm not driving anymore.
Okay,
Just
cool.
at work now. But yeah, that was a Blender animation. I like to make little Blender loops, and this was a fun way to kind of take that to another level.
Cool. Yeah, it looks great. I love the color and just like sort of because of this effect, you get that sort of starburst feeling from it. Seems like everybody in this class is doing stuff with like fun Blender tools. So, yeah, that's nice. And it's also nice because then you can have sort of that fixed loop. So, cool. And I think Sarah posted some stuff from the end of class last week that are also cool if you haven't checked those out. Sarah, do you want to say anything about those?
No,
Fair enough.
they were fun. I like making static out of a thing that made sense. That entertained me. I really like these effects, but yeah, it's just playing with the numbers and spitting them out. I tried some other stuff that actually was incredibly not successful, so I didn't post any of it, about trying to sort of combine overlays and slit scanning. So maybe someday there will be a thing to share, but not today.
Cool, not a problem. I also tried some stuff this week that didn't go very well, and I'll show some of that because I'm a glutton for punishment. And Tom also had some good questions here about sort of like how to work with bigger file sizes. It sounds like he's also running into some issues with Windows. So if anyone here is a Windows user on Ffmpeg, Tom, go for it.
Well, no. So I'm running into problems in both Windows and Mac.
Okay.
So all the stuff I posted, I'm sorry for posting confusing questions in Slack, but so all of the things that I've run into in the last 24 hours has been on my Macintosh command line.
Okay.
Because I haven't been able to figure out how to get my Windows command line to work. Like I just couldn't navigate to the right folder. It would just refuse to do all of that. And so it's been a little bit disconcerting. And yeah, the comment about breaking my computer, I did realize earlier this morning that I had just run a command that was rm something, something, something. And I'm like, wait a minute, that's a remove command. I probably shouldn't be so flagrant with that.
Yeah.
I have used Terminal for a long time now. I mean, I'm familiar with it. I wouldn't say I was good at it, but I know enough to know I shouldn't be using RM commands without thinking about it. So
Yeah, I will just also say like FFmpeg in particular does, especially if you're running on long files or large files, that is, you will definitely like run into places where you feel your machine slowing down. It might take a very long time depending on the command you're using, like lots of sort of things. So it is definitely like something to be somewhat careful with. A thing that I definitely recommend for everyone is work with short videos or smaller videos first until you have your command sort of like perfectly like set up, and then work on a bigger file, just because the other thing is the feedback loop is so slow if you work with large files immediately, right? You have to wait 20 minutes for it to finish, upload, look at it, see if it worked, redo it again. So that's generally how my approach is. Like I'll work with something very small, or I'll work with like little components of it first and build up my whole command before I throw a huge thing at it. Just in part because I know that even like sometimes like I'll have a video that works fine at like a certain length or a certain timeline, and it seems fine. And then I like make it larger or bigger or longer, and I run into issues, and I have to like debug there. So yeah, this is like it's not an easy solution. And then I would also say like one of the things I do like about Colab as a whole is that like it is sort of an isolated environment, and if you like destroy shit like there, you just like sort of like reset it and you can go back to it. So obviously I think the command line is nice, and like if we can work directly in it, it's much better. But I do find that sometimes, especially for some of this more experimental stuff, where like who knows what this is going to do to render times and that sort of thing. I do think it's sort of sometimes smart to just work in Colab to just start and like figure things out and then go from there. Stefan, looks like you added a couple of things as well.
Could I just ask if?
Yeah.
Apart from,
Yeah, totally.
apart from uploading. Sorry.
No, go for it. Sorry, Tom. Go ahead.
Real quick, so if, apart from uploading, is there a limit to Colab? Like if I uploaded a 2 GB file, would it jump through it eventually?
Yeah, I mean, so Colab, depending on if you're paying for Colab or not, Colab Pro is $10 a month. Probably don't need it for this class or like for doing Ffmpeg stuff. I usually recommend it for my machine learning folks, but for this, you're probably fine to not pay for it. But yeah, it'll run, I believe, up to 10 hours on the free version before it crashes on you. So if you have a big file, you can run it for quite a while on there and it'll be fine. And there is also a command line interface directly for it. I'll show that when we jump into the notebook as well, just so people are aware of where it is. So yeah, you can sort of get the best of both worlds. And then again, you're using like a Google VM instance. You can just sort of like, you break it and you're just like restart, whatever, you know, it's like, it's kind of flexible in that way, which is what I like. The other thing I'll say is if you are on a Mac, when we get to the Python stuff, you might want to also look into like an environment manager, like Anaconda or just venv, because Python on the Mac is kind of obnoxious. There's like multiple versions of it. So I can also share links with that sort of thing if anyone's interested in more material like that. Cool. Sorry, Stefan, I didn't mean to cut you off there. So go ahead and chat about this.
Oh yeah, no problem at all. So this was just something I threw together really quick. It's 2 slit scan instances on like a really small video. It's only 540 pixels wide. So this was with a strip of 4, and it retains a lot more of the like it looks more like the original video, even though it's sort of skewed off to the left.
Mm-hmm.
And then you know, the people sort of phase across it.
Mm-hmm.
The other one is like kind of I did a strip of 2 on that same, you know, very pixelated starting video, and it kind of really like slowly makes its way down the frame, and it's essentially just one long skew across that then arrives at the end frame of the video.
Cool.
Yeah, so I had a little bit of trouble just with getting my head around the Python integration stuff to like try and do more with it, but I also should have spent more time, but yeah, I'm looking forward to more, so yeah.
Cool. Yeah. Yeah. And obviously, like, this isn't really a Python class, but if anyone does have issues with, or like wants to like have like a quick Python intro, I'm happy to set some time up to do some of that as well. You know, my hope is that I find Python fairly readable, but that might also just be like, I use it all the time, so I'm like, yeah, this is fine. You know.
Oh yeah, it's basically a new like Mac install for me. Like,
Oh, okay.
So I have to like reinstall like everything, and it's just like, oh crap, I haven't done that yet.
Yeah, cool. I will share a link with using a package or an environment manager to like Anaconda for people, because I do think something like that like sort of makes everything a little bit easier, and especially if you get into multiple Python projects, a environment manager is going to be far more sane for you, because Mac, I hope new Macs don't ship with Python 2, but God knows they probably still do. So there's all sorts of like versioning issues, that sort of thing. So I'll definitely share some resources for that, because I do think it's helpful. And then I would also say, like, again, maybe the reason I did this work in Colab for this class is just like, you can kind of avoid all those issues by just playing in Colab for a little bit. I know upload download is like really annoying in Colab, but I do find it's a little bit safer of an environment to get working and not get stuck in like all the dregs of Python and like compatibility and things. So yeah. Cool. All right. Well, this is awesome. Hope to see more work. And again, like, since we will try to do something like a a show and tell in a couple weeks, it'd be great for people to continue sharing work there. And like literally what you're sharing in Slack is what you can share in that show and tell. Like there's no like, oh, I have to make this grand, project for this class. It's just sort of like make some stuff, share it, because I think it's sort of a nice like culmination of the class, just sort of see what people have produced. All right, so let's jump into material for today. So I sort of have just like a little bits of everything for today's session. So I'm gonna try to sort of move through things quickly, and hopefully I've got like notes and stuff here as well. But won't cover everything that I think we've talked about. Again, it's sort of like four weeks is fine for an Ffmpeg class, and now I'm like, oh man, I need like a 10-week class here. Well, which maybe we'll do. Maybe we'll do that in like the next session will be much longer. But I'll cover a couple materials of things we discussed covering last week. So we'll go over making Gifs. We'll go over scene detection. I'll talk a little bit about encoding and how to keep your like file formats as good quality as possible as you're sort of moving through different things. And a little bit of streaming. I just mostly have links to some streaming guides, but I'll talk through sort of what I've experienced in those cases. So let's get started. So let me share this notebook with everyone. And the first thing that I'll mention, okay, so a couple things. So I mentioned to Tom that you can use Google Drive. Yeah, I'll add this to the class doc as well. It's usually I just update the class doc whenever we have the recording. So I'll make sure that's updated there as well. So I mentioned to Tom that one thing you'll notice is that uploads to Colab are really, really slow, right? So if you drag a video over here, and let's say your video is like a couple minutes long, it feels like it takes forever to upload these. So one thing that you can do is you can connect, because these are Google products, you can connect Drive and Colab together using an import. There's this little piece of code, which is here. When you run this, you'll be asked to sort of like authorize your account. So you authorize, I have multiple Google accounts because of various jobs and things. When you authorize it, you'll get this little code. You'll copy this code. You'll come back to Colab, you'll paste your code in, hit return. And what this will do is it will sync your Drive account into Colab. So you actually have a folder here that will say Drive, and inside of there will be all of your Drive files. And this uses some sort of syncing process. It'll be able to talk to each other. One thing you'll notice is that uploading files to Drive is like 2 times faster than it is to Colab. I don't know why. It seems kind of weird that they're both Google products, but for whatever reason, Drive is much faster. So if you've got large files to upload, you may find that it's easier to upload them directly to Drive and then import them this way. And then also, you can save files directly to your Drive account from Colab, just like it's any other file path. So this is this Google Drive is now a path here available to you. So if you want to save something to this, you can. And again, downloading then is also much faster through Drive as well. So one thing to note is just like it's a little bit easier to work through that, especially if you have large files. We'll look at one example of this today. So that's just a quick note about that. And then in our co-working session on yesterday, James, Diego, and I sort of walked through a couple examples because James was having issues with the trim filter. And then I was like, that's weird. And then I ran it and I had the exact same issues with the trim filter. And this is that when you use the trim filter, if you set your, so essentially this is a video that we want to clip just starting at 10 seconds to 20 seconds. So you want a 10-second video that clips starting at 10 to 20 seconds. When you run this, what we got was actually a video that was not 10 seconds long. It was actually the whole length of this video, so it's 50 seconds long. And the very first frame for the first 10 seconds was this 10-second frame. So it was like repeated, and then at 20 seconds, so then from 10 to 20 seconds, it actually played. And then at 20 seconds, we got the very last frame of this here, and that played for 30 seconds. we were trying to figure out what was going on. One fix was that the set points wasn't working, so I added this. Then what happened is then when the video loaded, it started playing just 10 to 20 seconds. And then for 40 seconds, we had this frame. So we kept playing back and forth to try to figure out what the hell was going on here. And I actually didn't figure it out at the end of the session. But what I found after playing with this more was that even though this video is silent, there was actually an audio track in it. And what was happening is the audio track was still being read as being 50 seconds long. So the video just mapped to that length, right? And all Ffmpeg did was like, okay, if the video is only 10 seconds long, I will stop it, or like I'll just play the last frame for however long I need to be. So the fix for this, in this particular example where we didn't really care about the audio, was to add the AN argument right after, or basically before you run the video filter. And what this does is just like drops the audio channel. So this acted like there was no audio channel whatsoever. And then when I ran this command, I got exactly what I wanted, which is a 10-second video. So one thing I'll also talk about this next, for the next part when I talk about the homework I tried from last week, is that for complex filters, as well as for some of these video filters, like you just take into account your audio track. And there's different ways to like sort of hack around this. One solution is just to drop the audio track, but if you want to keep the audio track, you do have to consider like what's happening with the audio track. In this case, another solution would have been, if I wanted to keep the audio track, would have been to remove the AN and add an additional AF filter. AF filters are audio filters. And usually in this case, there's like an analog to this. I happen to know that it is A trim. And then I believe there's also an A set points. So as we didn't really cover audio much in this class, but as you get through audio stuff, you'll find that there are additional things you have to worry about and other hacks and things. So yeah, so just want to make notes that like dealing with audio in videos is also kind of annoying, especially with Ffmpeg. So you do want to sort of think about like how you treat those different pieces. And then I will also mention that I tried to get the homework example, or like my brain teaser example, working from this week, which was that Martin Arnold video that sort of had that like stuttering effect. I thought it was gonna be easy. I started last night at like 8 p.m. and I was like, okay, I'll just quickly whip this out in an hour. And like I looked up and it was 11 p.m. and I was like, fuck, what the hell is, where is this thing? Why isn't it working? So I kind of stopped because I wanted to finish out the rest of this notebook. But I will say that I got a decent way through this. I got the video working pretty quickly. But again, the sound syncing was actually one of the harder parts of this process. So I can quickly show where I ended up with this for anyone interested. And I left all my code here, so if anyone wants to play with it, you can. But it definitely did not work exactly the way I expected it to. So let's see here. All right, so here's my video. So you'll see what I did is I've set it so that like it starts, and then as each segment gets a little bit longer. So like you can sort of think about like the first is only 2 frames, then it's 4 frames, then it's 8 frames, and it's, I think it was just adding. So it's 2, 4, 6, 8, 10, 12. So as this video gets longer, you know, it starts when it's like very stuttery, and it gets longer and longer. It just repeats. So that is, you know, simply all I'm really doing is I'm splitting my video just a bunch of times, and then so I'm taking the full length of the video, splitting it maybe 25 times, and then for each of those splits, I'm starting with a very short version using a trim that is like 2 frames. Then the other one's 4 frames, and the other one's 6 frames, 8 frames, 10 frames, 12 frames, etc. Until I get to a point where like I've got all my frames, and then I concatenate all those into a sequence. So that's fairly easy for video. And then I added another version that would also do reverse. So there was, let's see if this one. So this one, instead of just going and starting like right, you know, start only playing forward, this one goes forward, backwards, forward, backwards, forward, backwards, forward, backwards, etc. So kind of fun. The challenge here was adding in the audio pieces. And I thought what I could do is I could just split them out as like, okay, let's just do all the video, and then we'll do all the audio, and then we'll combine them. And for whatever reason, I couldn't get them to sync up. So I kind of need to look at this again. My guess is that there's something where like I actually just want to keep the audio track as a part of the video track, and like not pull them all apart and then put them back together. What ended up happening was, and I'm going to sort of show this. Let's see if I have a good example of this. So at this point, you might be able to tell the audio is not synced correctly. Now, first off, that's kind of funny because the audio isn't great in this video anyway. But it just like, yeah, for whatever reason, I couldn't get a sync up. And I think it might just be that there's some sort of like clipping issue going on using different sequence formats. I mean, the thing you have to remember is also that video works in sort of frames, right? But audio actually works with a sampling rate. And there might be some issue there where the sampling rate and the frame rate are not really aligned in the way that you expect them to be. So this is a fun example, but it was definitely a failure. So just so you're aware, like, even though I know what I'm doing here, or like potentially might know more than what you're doing here, I'm still screwing up all the time. So like, don't feel bad if this is hard to you, because it's, I think it's gonna be easy, and then I sit down and I'm like, oh, this is actually a really hard problem to solve. So all the code is here. It probably doesn't work the way you expect it to. Like, I would say if you just want video, I've got a little like variable here that you can just turn off audio. This one should work just fine. So if you turn off audio, then you will get a video that can sort of do fun stuff, and you can sort of play with it. You'll see here there's like a starting value. So this is how long into the video you start. There's an end value, and then there's an increment set, which is based on frames per second. So you can sort of play with that and see what you think. But yeah, I also failed just trying to get this up and running. Any questions about that? Other than like, how do I make it work? All right. So that sort of just covers everything we've talked about in the past week or so. So now I want to jump into sort of new material. And this is, so there's a couple things here that we talked about over the past couple weeks that I will cover. So one thing is, I know that right now we're working mostly in Colab, and you're sort of like, Colab's great, but like, what if I really want to do this in the command line? So I think, I think Chris had asked about this last week. How do we take these sort of really complex examples and actually use them in the command line? And there's sort of two ways to do this. One is you could actually try to like spit out the entire command and then just like copy and paste that into your command line. That would work fine, but that's like, in some of these examples, we've got a really, really, really long command. And if it breaks or doesn't work the way we expect it to, like, how do you fix that? It's really hard. So I'm going to show a second example here, which is actually like just converting these to Python scripts and then using a Python script in the command line. So this will still essentially be mostly just running an Ffmpeg script, but you actually do it from Python. So I'll show you just two examples here. So the first is, you can actually write these directly from Colab. Colab has this cool little feature called write file, which allows you to write or create a file from a cell. So what we're going to do here is we're actually going to generate this Python script. .py files are essentially Python scripts. You run them from the Python interpreter, and it will allow you to run Python from the command line. So what we'll do is we will create a file that just happens to be called this, using the code that's in the cell, and then we'll look at how to actually use that both in Colab, but then also we can download it and we can play with it directly in a command line tool. So this is actually an example from last week, and this example was, I believe this is like some rotation, hue shifting, other things. So here's the whole filter that we wrote. And all I did was I copied this filter and pasted it into a single line, because previously we were using those backslashes just so we could stack it. You can't really run backslashes in this, so you have to sort of combine it into a single string. And then we're going to write filter equals, and then just turn that into our filter. So basically, like, all we're doing is we're sort of going to take all these pieces and move them into a Python script. So next is you're going to need to run the actual ffmpeg command. And you can do that from a Python process called subprocess.call. So this is all Python in here. So first thing we're doing is we're going to import two libraries. So we're going to import Argparse Argparse is a very, very popular Python library that allows you to essentially like generate variables directly from your command line. We'll look at it, how this actually works in just a minute, and we'll look at how to implement this. But this will allow us to set input and output from the command line without having to like open the Python script, edit lines in there, and then run that script. And then we're going to use subprocess, and subprocess allows us to call command line commands from Python. So maybe I should just read this top to bottom. I think it's gonna be easier. So for Argparse, I honestly never remember how this code works. I just literally copy and paste this from like every example. So I've sort of written this as a template that you can now use like as you want to. So really, if you just want to take this whole template and just all you need to do is edit these 2 lines. So you've got your filter, like that pretty much just works. But I'll just walk through how this actually works in case you want to edit some things. So for Argparse, you need to find this parser line, whatever. Again, I just copy and paste this and then I edit whatever the description is. And then for this parser variable, you're going to add individual arguments to it. And what these arguments are is from the command line. So actually, let me just open my terminal window here. And let me make this one bigger. So what our essential goal here will be is we will want to, let me make my font bigger. We'll eventually just want to write a script that goes Python myscript.py, and then we want to be able to set both the input and the output file paths from here, right? So we want to say my input video is, slash like desktop/video.mp4, and then I want to be able to say where to put it, which is like, okay, let's do output desktop output.mp4, right? So this is what Argparse allows us to do, is allows us from the command line to set these 2 variables. This way, the other way you would have to do this is like open up the file every time, edit a couple path variables, and then close it. This makes all that a little bit easier. So that's all Argparse does for us. So in this case, we can define I guess what you would say is like the sort of like main name variable, but you can also set up shortcuts. And the shortcuts are where, most people are sort of like, this is where the coding people come in and say like, oh, that's too much to type out. So you can also type in shortcuts. So in this example, both of these will work. So once we have these arguments, we then parse them all using this args command. So all these will be saved as args variables. So it'll be args.input, args.output. So then again, here's our filter that we're going to run. The command that we will then run from Python is going to be just a traditional ffmpeg command. So all you have to do is really convert your usual ffmpeg command into a string, and then add in your variables, right? So we have our input variable, which is using the args object. So you'll be args.input. Your filter goes here, and then args.output goes here. Now, what I like about this is that you can also sort of build in all of the nice QuickTime stuff and like other codec things you need to. So you don't really need to worry about remembering these ever again, right? So this template minus this filter is pretty flexible. Like you could edit this filter to be anything, and then run this script to generate the file, and then you can process anything. So this is like a pretty nice template. So hopefully if you do want to do more with this, you can use this in the future. So I'll go ahead and run this cell, and what we'll see is that it writes a file for us called HughScale script that goes here. So yeah, so I think this will be like kind of helpful for people going forward. So now we have this file. If you're in Colab, what you need to do is you need to do !Python, and then the path to the script, and then your input and your output. So run this. And you'll see you get all the same ffmpeg outputs here.
And Derek, just to confirm, we could just use like Sublime or whatever and have a text copy of this template.
Yeah, let me show you how to do that. Let me show you how to do that now. So that's actually a great point. So the other thing is you can download this file directly from Colab, and then you can just open this file. And yeah, you can edit this file in anything you want to. So we could open this in Sublime Text. So now you've got the exact same code here, right? So all you need to do is edit this line, save it again, and you can work with that. And then for local command line, all you need to do is you'll do Python without the exclamation point, and then you'll want to point it to the path for this. Okay, Bug, just a second. So point it to there, and then you'll do input. Just go ahead and find a video really quickly. Come on, stop yelling. So let's just grab a video. And then we'll define our output. One thing for folks who are using brand new Macs, or like, I guess not even brand new Macs, it might be a Python, you might have to use Python 3. This is like one of those like gnarly issues with Macs where sometimes they have Python 2 and Python 3, and I never know which version is which. So just beware that like if this doesn't work, the solution, or if you get an error message, the solution might actually be to do Python 3. I really hope Mac stops shipping Mac Python 2 because it's been deprecated for like 2 years now, but you never know. So this will work. So yeah, so basically now you have a way to bring all of this down and edit things directly. So likewise, one of the other things you can do is you can also, some of the more complex commands that we've written before can also be done in this exact same manner, right? So you've seen some of the code where we have this like really complicated, Python script here, right? Where we're building up a really funky command. And all I did was I just copy and pasted this from one of our previous examples and dropped it into the middle of this code. And then at the end, my filter command was just this combined command. And all I did was pass that into my ffmpeg command variable. Now, in this case, I had some additional variables. I had one called vid length, I had one called offset, and I had one called count. And I used those and brought those into the Argparse system. So instead of setting them directly as like strings or floats or whatever, I then can set them from the command line. So just beware that one of the things you want to worry about is exactly what the type of input is. So input, output are strings. Vid length is a float. Offset was a float, and count was an integer. Make sure you define them correctly because they will throw errors if you don't. You'll see you can sometimes set defaults. You don't always want to set a default value, but you can if you want to. And then again, those get used as args dot. So I have one called vid length. So there's args.vid length, args.offset, and args.count. So those just get used here. So this is again like a really nice way to have all the power of Python, but still have a pretty clean command line interface. So in this case, I've just written this one. So it's called script scale variable. And there it is. One thing about this particular script is I need to know the exact length of my video. So I'll use ffprobe to just run this. And right here is my duration. So it says it's 50.6 seconds. So then when I run this command from the script interface, I'll give it the input of my, I'm going to switch this out to flowers. .mp4. Actually, I should figure out the length of that video. That is 24.21 seconds. And then, just this is that that blot, the sort of scaling effect one. So I can set the count, the variable count here. So I'll set this to, let's say 50. And then I want to make sure that my, so this is still 24 frames per second. So I had set the default for the offset here as 1 frame or 1 FPS, assuming that it's 24 frames per second. So this is still correct, so I can use this. So I'll just run this. And what I've also done in this script is I've still printed out my individual commands, just so in case there are issues, I can sort of double check them here, right? So I've got at the very top here, just sort of like what the outputs are. And likewise, I could download this and I could run this from the command line. Oops. See if my computer will not explode on me. So go back over to the terminal. So we'll use this script and we'll do our input as, let's grab a video over here. We'll do our output. And then, well, we'll need to figure out how long that video is. So let's actually do this instead. Let's grab this path. FF probe. Okay, so that video is 4.88 seconds. So we'll do this again. And the length is this. So we'll do -- vid length. If I could spell, that would be easier. And then we want a count variable. So let's do 50 again. And so my previous video was this one, which did not work. I'll have to check out why that is. My guess is that the reason that one didn't work is because I had some sort of like looping filter that didn't work because of the length of that video. These are both really short videos, so I wonder if there was some issue with that. Let's see if this other one worked better. Yep, that one worked correctly. Yeah, so there's that effect. Oh, interesting. That's really cool. So there you go. So this is a really nice way to just sort of have the power of Python and be able to run FFmpeg together. So again, I would just recommend maybe using that template. You can probably, maybe as an example, try to take a bunch of stuff from previous examples and cut and paste it and try to work with it within that template. And if you run into issues, that's a great thing to just try to debug over Slack together. Any questions about that process? Cool. So you don't have to use Python, right? There's probably other ways to build up this command. If you're like a bash person, bash might be like a bash script might even be a better solution to this. Who knows? I just happen to like Python because one, I use Python pretty frequently, and Colab is by default like a Python friendly interface. But there's other scripting tools you could do. Remember, all that you're really doing is you're building up whatever this combined command needs to be. So you could do it in PHP, you could do it in any number of things. Whatever you're comfortable with, as long as you can build up the correct ffmpeg command. So if you know how to use PHP scripts, you can do that. I guess you could use JavaScript for this. Like, I guess it would be Node. Yeah, Node would work through this. Yeah, so yeah, so any way that, like, whatever language you're comfortable with, as long as you can sort of combine strings together and do looping, you're pretty much like set to go there. So yeah, any of these would work. Yeah, I guess OpenFrames would work too. It feels like that would be like writing a lot of like C files in order to generate an Ffmpeg script. But yeah, it works. Whatever. I mean, again, like the whole point of, I don't know, people freak out too much about coding and being like, you have to use the right tool for the right job. It's like, if you're an artist, you have to do the right tool is whatever works for you and whatever you can get done. So, you know, whatever you want to use is totally fine. But here's some simple Python examples if you're interested in that. Let's see. Why don't we take a break now, and then we'll come back and we'll cover the rest of this material. So why don't we do a 10-minute break? So we'll come back at right on the hour, and then we'll jump into doing a couple other fun things. So I will see everyone in 10 minutes. Were there any questions about the material we looked at previously? Was anyone able to get a Python script working locally over the break, or did you actually take a break?
Took a break.
Good call. Definitely not against that. Okay, so that's fine. Definitely try this and let me know if you run into issues or not. And we'll try this again. Maybe during a co-working session over Slack, we can play with that some more. So let's take a look at Gif creation. I think Stefan, you had asked about looking at this. I personally I find making GIFs in Ffmpeg pretty much one of the best outputs. Like I find just it produces some of the better outputs of animated GIFs. And it's actually a fairly easy process. It takes 2 steps. So look at those steps here. So the first thing that you need to do is you actually need to generate your palette. So if you've ever used Photoshop's GIF maker, you'll know it's that little rectangle of all the little colors you can use. So we'll actually generate our palette. And from that, you will use the video filter of palette gen, and then you can set a max color. So we'll look at 2 of these. So let's start with a really small color palette. So we'll use a color palette of 16. I believe these are usually powers of 2s, but I don't even know if that matters. Let's actually take a look at the palette gen documentation. Palette gen. So max colors. So if you set it lower than 256, it'll still be actually 256. The rest will be black. You can reserve a transparent color for that if you would like. I guess you can also set the transparency color. And then it looks like there might be some additional values to compute particular ways in which you compute those color palettes. So let's start with a max colors of 16. So we'll go ahead and run this. So I assume the process is some sort of histogram running in the background. It's looking at every frame of the video and computing histograms on, what's the most used colors, what's the best in terms of just processing for the outputs. This takes longer than I remember. While this works, okay, I already have Photoshop up, so that's good. So we'll take a look at this in Photoshop to actually see, because I think there's some fun stuff you could do about sort of corrupting this file or changing this file and then utilizing that as a way to output some new colors. This takes surprisingly longer than I remember. So I bet I have one of these on my desktop somewhere, so let me just find one real quick. Yep, here we go. So this isn't the 16 max color one, obviously, but what you'll get in the end is a very small little file like this. and inside that file will be every one of the color palette colors that it just determined. This looks like it was clearly using 256, right? So if it's 1, 2, 3, 4, 5, 6, 7, 8, yeah, this is 256 wide. So what it's going to do is it's going to take this palette gen, and then what you can do is run the next command, which is palette use, and palette use then also takes in a couple examples as well. So this, again, if you're used to Photoshop, you know there's different types of loss dithering inside. I said githering, dithering in with using Gifs. God, I'm gonna be tongue-tied this week. So with dither, there's a couple different processes. There's Bayer, there's Heckbert, there's Floyd Steinberg, Sierra 2, Sierra 2, 4A, and it looks like the default is this. And if you're using the Bayer dithering, there is an option for the scale of the pattern. So this is like I guess some sort of pattern or crosshash generator. So you can pass in a different value within the range of 0 or 5. It looks like there's a couple other values in here, but for the most part, this is all we need to worry about. So we're going to generate a GIF using the palette use equals dither equals Bayer. So I'm going to use the Bayer. Actually, we can just remove this and just use the default and see what that looks like. So in this case, what you do is you take in both the video you're going to use as well as the palette. So this takes in 2 inputs, which means you do have to use the filter complex or the complex filter graph. So we'll go ahead and run this and make sure your output ends in a .gif, .gif, whatever you want to call it, file. And so what I was saying is if we download this file, and we open this in Photoshop, these are the colors that it's decided on. And what I think could be really fun here, right, is you could go in and take one of these colors and you could say, like, I don't know, actually make it this bright green color, right? So there's some options here to sort of glitch this thing where really all it cares about are what the actual color values are. So you could probably have fun. Oh, you can't do that. So you could then save this out, re-upload it, and actually use this as your input. So I think there's a lot of fun options that could be had to play with here as you do GIF building. Another thing that I've done in the past is you can generate your GIF from a different video than you're using the input for, right? So you could use, you know, some really brightly colored video to generate your palette, and then you could use that same palette on like a much more maybe, I don't know, desaturated video and sort of see what happens. So there's lots of like tools to play with here, and this is what I really like. And also I find that these dither options are also like just some of the best in terms of what's available within these pieces. So I think there's like definitely some cool tools to play with here. Clearly this render takes far longer than I remember. I think probably because this is a fairly large size video. Oh, so here's what happened is I'm running this on a 1440 by 1440 video, so I probably should have scaled that down beforehand. But I think this is still like just a fun process, and we'll take a look at this while this runs. Yeah, and like, so yes, this is also good for Twitter use as well, because you can get around the compression curse a little bit. Although I think they've like, I feel like Twitter changes their mind on these weird compression or like how it operates on all these tools like pretty much every 6 months. So I've also seen that some GIFs are starting to get compressed in different ways too. So it's definitely a challenge to figure out how to work with that. But yeah, I think there's lots of opportunities to play with this. I actually had a project where I had to generate a GIF from one of my videos so that I could go in an email, and it was a nightmare, but actually Ffmpeg made it far easier because you can play with these values as well as the scale of your video like really easily, right? Like this could be written into like a complex filter, where what you actually do is scale your video down, then create the GIF from it, and then also like generate your output from it as well. So I think there's lots of like cool tools to be done here. This one's still going to take a little bit longer. And then usually the last thing I do if I'm really worried about compression is I will what is easy GIF? It's not actually, is it have a Z in it? Yeah, easy GIF. This generally tends to be my last step for GIF prediction, just because there is a little bit of an optimizer tool as well, which will help sort of remove a bunch of like random metadata, that sort of thing. So no matter what, at some point I'm generally dumping stuff into easy GIF just to make sure I can get the smallest file size out of these things. But I've also done, I did a project, and let me see if I have this on my computer.
I'm always scared to put my stuff into like a random web page that's like, put something in here and then I'll do something to it and you can download it back onto your computer. So it's interesting to hear that you use easy GIF. And as far as you know, your computer has not started joining botnets or anything yet.
You know, we're all on some botnet. I will say easy GIF tends to be the one that most people use. So, and I think I've also seen like lots of other companies integrate with easy GIF. So I feel slightly better about it than say other tools that I know exactly what you're saying. But easy GIF definitely looks like one of those tools that is going to give you some like bad file path stuff back. So yeah, I definitely, I feel you there. But I will say, I think, you know, I've heard enough good things about easy GIF to sort of feel comfortable using them. I was going to pull up an example here of where I actually used the GIFing process to generate some rather interesting video. Well, these are stills, but this is that Bayer dithering process. And I actually used it to generate, you know, just some really nice texture for these images. So this is just, I believe, probably just using PNG outputs rather than the GIF outputs. But yeah, so there's lots of opportunities to actually use this as sort of not just a feature or not just a like make your video smaller tool, but also to generate more from this. Yeah, this one's still chunking away, huh? Give it one more minute, and then I'll just force quit it, and then I'll generate it later, and then I'll share it through Slack. It'd be really nice if Ffmpeg could give you some sort of like bar about how long this process is going to take. I know the reason that it can't is because it doesn't actually know how long a video is until it finishes it, but just still kind of annoying. You can sit here and like, how is this like, am I 10% of the way through this thing? Am I 30% of the way through this thing? How much time is left here? All right, we're just going to stop this process. We'll come back to this later. So I'll finish this video and I'll share it through Slack if anyone wants to look at it. But that's how you generate GIFs. And then obviously you can change your number of colors. So like I said, it'd be 256 if you wanted to. Run that, you would get more color range. Yeah, any questions about GIF creation? All right, we'll move on to the next section. So now I've just started, maybe got like some things to check out, but I don't really have a whole lot of example content to look at here. But some things I know that Chris was asking about last week as well, where, you know, what's the process to keep the quality of these videos as high as possible? Like, what are other things I need to worry about in terms of, you know, adding compression over and over again? So I just have some basic sort of like default, if you are super worried about compression values or keeping your quality high, a couple of things you can do. So another thing that you will also probably find is like, as you start to like Google these questions about like, how do I do this in Ffmpeg? And you end up on Stack Overflow and you see people have been fighting since 2007 about whether or not you should use something that re-encodes or doesn't re-encode. Re-encoding is like just one of those really popular debates within the video community. So, you know, essentially re-encoding is that you want to like, you will often pass your video through Ffmpeg and you won't even realize what it's doing is it's like essentially re-encoding your video, which means it's either adding more compression, changing the bit rate, changing some other setting into your video, and therefore it is altering the quality of your video. The very, very strong opinions of video people on the internet is that you should never re-encode your video unless you have to, and I think that's probably true. But you know, for most purposes, stuff gets thrown up on the internet onto Twitter or YouTube or Vimeo or whatever, and it gets compressed anyway. So it doesn't really matter that much, in my opinion. But I think it's, you know, it's good just to know about. So you do want to avoid re-encoding if you don't have to. So a really good example is this. So this line here is just basically converting a sort of MP4 into an MKV file. And you might think like, well, this is all it's really doing is just doing the conversion, right? It's just taking this file and doing this. So it makes an MP4 into an MKV. And what really happens here is actually you're re-encoding your video. You're re-encoding the video because there's a lot of defaults in Ffmpeg that aren't set here. And therefore you are actually like reprocessing your video. So if I run this, okay, I guess oops, that's written wrong. So -I. So if you run this, you'll see this process takes a not insignificant amount of time, right? And basically, if something's running about this long, at this point, you know it's re-encoding. If you are not re-encoding your video, it should be a very fast process because it's basically not, unless you have like a 10-hour long video, re-encoding is very, very quick. One thing I do like to do is if you look at this on your local computer, actually, let's do this. I think this is helpful to sort of see locally. So let's just take this command. And do Command K. Paste that in. Let me make sure that my video actually exists. So let me grab. I have a really long video here, so let's grab this one and actually just show what happens here. So we're going to take this, which is an MP4, and we're going to convert it to an MKV. What's my error message here? Overwrite, yes, let's overwrite. Actually, that's not overwrite. Sorry. let me rename that just so I'm not overwriting my files. Test. So if you see here, see how long your FP, like your frames per second rate is. This is like fine, but I can tell this is like still fairly slow. Basically what we're doing here is we're re-encoding this video. The way to not re-encode your video is to actually use the -c copy command. So -c copy. What this says is instead of taking this and re-encoding it, it says just copy the encoding into the new container. Containers get really complicated, but essentially MKV is the Matroska container. I don't know what, MP4 is the different version. It's like the one that QuickTime uses or whatever. So often you will see people sort of say like, oh, I don't want MP4 because it's a QuickTime, it's like copyrighted or whatever, which is kind of bullshit. But anyway, you'll often hear people say like, give me a not like an open source format, which is MKV or something. So this process should be much faster. So if I run this, it's fine if it overwrites. See how high my FPS is? This is how many frames it can process in each step as it's running. So before it was like 44, now it's like 10x that. So that's a good sign that I'm not encoding my video. And essentially, like this video, the quality of this video should be the exact same as the other version. It's just in a new container. So this is like an example of a non-encoding or like not encoding, not re-encoding to reprocess your video. So essentially, there should be no loss of quality in this conversion. And again, that's where like people get really uptight about like, oh, you're losing quality because you're re-encoding. Again, everything goes up on YouTube today and it gets mangled to hell anyway, so like who knows. But if someone's really adamant they don't want to lose video quality, like that's how you do it. So that's the example here. And the last thing I'll say about all of this is like if lossless or if like lack of video quality is really important to you, or like lack of loss of video quality is really important as you move through all these steps, there's two things you should think about. The first is that when in doubt, try to use the complex filter graph, because the complex filter graph, if you can do everything in one line of code or in one filter graph, you shouldn't really lose any quality in the way that it operates. The second is when in doubt, if you just want to keep the highest lossless quality, if you use CRF0 in a process, so like if we were to do this here, there might still be some compression or whatever. CRF0 will always give you like essentially lossless. There's a link to like a Stack Overflow like debate over whether that's really true or like if there's some other thing you need to set as well. But for all intents and purposes, this is going to give you the highest quality video possible. So say you're taking frames from a 3D rendering that have also they're like really high res, whatever, and you're like moving them through a compression, and you don't want to actually compress the video. This should, for all intents and purposes, give you lossless quality. So if you're going to instead do like, okay, I'll run this command, and then I'll run this ffmpeg script, and then this ffmpeg script, and then this one, if you keep CRF 0 as you go through all those scripts, you shouldn't really lose quality. So when in doubt, just add this to your script. One note about this is that CRF 0 will obviously lead to very, very large file sizes, right? The reason we have compression is so that it like doesn't turn into 10 gigabyte long size videos. But if you don't care about that, or like for a reason you really want to keep the highest quality possible, this is a safe bet to make sure that you sort of keep that as you go through these processes. Yeah, so just adding that, and again, this is a great place of where these little Python scripts can really come in handy, right? So let's say I know I want it to work for QuickTime and I want the highest quality video. Here I could just add this in, and I never have to remember what the command is. I just have it as like the default here. I could turn this into an argument that would basically say like, you know, if lossless, like you could add in another argument here, like let's say, should I never remember how to do true. I think it's say lossless. I believe then the value is store true. Let me Google this really quickly, because I'll just add it here. There we go. This is how you do true false in Argparse, which is super annoying. So we'll say lossless equals this. So this is basically like from your command, you would say, if you add -- lossless, that'll be true. If you don't, it'll assume false. So then what you could do here is you could say, if args.lossless else, your command would be this without. You could even set the value here. You could say like 17 or something if you want the quality to be a certain way. What did we decide the default was? Like 23 or 18? I forget exactly what it was. But essentially, this is a nice way you can build up these little scripts to like help manage these for you as well. So that's sort of a nice way to make sure that you've got that as well in your scripting process. Yeah, so that's sort of my like my top tips for encoding as well as for keeping quality going. There's probably way more. Like what specific codec do you use? Like all these other things. I don't generally care about them because they mostly share to the internet where they get compressed to hell anyway. But if for a reason, if you're doing like an installation or something and you worry about that, knowing what codec people want stuff in is helpful. And usually there's ways within Ffmpeg to set a specific codec. One thing about codecs is that sometimes Ffmpeg doesn't ship with them, and you have to install them and rebuild your Ffmpeg. That is a pain in the ass, but it is possible to do. Ffmpeg now probably ships with the most common codecs, unless there's something really weird that people want. You can do that. Any questions about this material? All right, on to the next thing. So I mentioned last week that I would also share this script, which allows you to break video into single scenes. So, you know, for a lot of the stuff that we've looked at in this class, one of the things that we want to do is we want to work with a single scene, right? Anywhere we add cuts, we're gonna get like introduce some weirdness, which maybe is good, maybe is bad. But let's say you have a long ass movie that is like an hour and a half long and you want to crop to like a couple different scenes. You might just go into like QuickTime and like quickly crop them out. But there is actually this fun function that will allow you to grab every single individual frame or every single individual scene. So I'll just quickly show how this works. There's a lot more you could do with this. This could probably be like a whole class in and of itself. But really quickly, just let me grab a video here that I have. So this uses FFprobe. You can sort of ignore a lot of this other crap in here. The key here is that you want to set your movie to be here. So you'll set your path to your movie. And then the real big key here is, oh man, this is going to be a nightmare. Never put spaces in your folders on Drive. I think I got all those. Okay, let's hope. Actually, maybe I don't need to since they're wrapped in quotes. We'll find out. Sorry. Anyway, the big thing to look at here is there's a thing called scene. And you'll see greater than and then scene. So the scene is a filter that processes every single frame in your video. And what it does is it looks for the difference in frame pixels, essentially. So scene will say like, hey, from this frame to this frame, I see this much change in the overall pixel values or the overall pixel differences. And then what you can do is you can set a value here. And this value says, how different are the frames? And if they're over a certain value, greater than, give me that value or give me that frame. So what this will say is this will say like, and this goes from 0 to 1. I believe, I forget the order. I believe 1 is the most greedy and 0 is the least greedy. We can look this up in a second. But essentially you'll you'll vary your values a little bit to sort of see how you get. When you run this, what it will do is it'll spit out all of the time codes or seconds values of where it believes scenes are breaking. Let's go ahead and run this and see what we get. And while this runs, let me look up the scene detection again. That. Okay, yeah. So, specify the level at which the scene change is detected as a value between 0 and 100. To indicate a new scene, a low value reflects a low probability, while a higher value means the current frame is more likely to be 1. Grab. Okay, this is different than what I've seen elsewhere. Well, I might add some additional documentation to this as I find it. So what you'll see here is we're spitting out all of these different frames, right? So as this runs, this is a film, so who knows how many cuts are in this movie. You'll see that it's spitting out times. And basically what this time is saying is this is where I think a cut is happening. So we'll say 3 seconds in, 4.5 seconds in, 19 seconds in, 19 seconds in. So I will say you have to play a lot with this value. And you might even want to take a look at your video and actually figure out like, okay, I think for the first 20 seconds or 30 seconds, I think there's a cut here, 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 and here, and see how these map. One thing I will note is, I think I mentioned this to James yesterday, one of the bigger challenges with this particular frame rate, or like this particular value, is that it can vary depending on the types of movies you're watching, right? Or like, so if it's a movie with a lot of fast action, and there's lots of fast scene stuff moving, even something like that is a pure, like, that is a scene but has a lot of hand motion or whatever, like, there can be a lot of change between each of those scenes. So you kind of have to play with this and sort of see what works. I've generally found that for the stuff I work on, like a 0.3 value tends to be pretty good. But your mileage may vary depending on what you're working on. So you'll see, like, this is still processing. This is giving me a ton of different information. So one of the things I could do here is, let me just stop this really quickly. So let's say you wanted to extract one of those times from this video. So what you'll do is you'll take your starting time and you will pass it in here. We'll talk a little bit more about what -SS and -T mean in just a minute. -SS means standard seeking, I believe, something like that. But it basically seeks to the point in that video. And then what you'll do is -T takes in a duration. So we'll do, let's figure out how long this scene should be. 4.904900. So that returns a value of this. And so if I run this, this should give me, and I actually point at the correct video path. This should then clip out a video that is just that scene. So James and I had a very long discussion about what -ss means. One of the big crazy parts of -ss is that it requires the order of operations is largely changes a lot. So let's build this up here really quickly. So if we do this, go down here, we'll do ffmpeg -i, and we'll make -i point at this video. So you will see long debates about whether it is better to do this or this in your command. Stack Overflow is filled with people arguing which is better. The difference here is, remember that how ffmpeg processes video is it just starts in the very beginning of the video and it just processes over and over and over until it finishes to the end of the video, right? That is a very slow process because it has to essentially read every frame. This says skip to the nearest, this gets into keyframes, which we haven't really talked about in this class, but like this says skip to the nearest keyframe that is at this time and forget trying to like read any of those frames up to that point. So this will be faster, but it's been argued that it's less accurate because of it tries to find a keyframe and then it tries to find this other thing. This, on the other hand, will be far slower, but will be more accurate. And right now, that video processed fairly quickly because I set a time that was really early on. Imagine if this is an hour-long movie. Imagine that I'm looking at what is 60 times 60, 3600. So imagine that I'm actually looking for an hour into this. This is going to take forever because it's going to process every single frame until it gets to that point. So this is generally frowned upon because it's like way too far, it's like way too slow. So what you see is other people have a hack where they do this. So this gives us very fast, and this gives us very accurate. Now what I've learned, or what James and I learned, is that reading through some of the ffmpeg documentation, as of a version ffmpeg, like quite a long time ago, I think 2.0 or something, this should be both fast and accurate now. So they still recommend this. I couldn't tell you if that's true or not, but ffmpeg now says this is fine, just do this. This is both fast and accurate. So I don't know. Basically, I would say try it, see what you think. I would have generally found that this process plus this process is a little inaccurate. And it can be kind of annoying to try to figure out why that is or whatever is going on. So this is a very like, this is not a perfect process, but I find it is far better than trying to crop every single scene out of a video manually. Let's actually see what this generated for us and see if it actually gave us the correct crops. Or like what matters to me for a process like this is that I don't have any, I don't actually have any, yeah, so there's actually a cut here. So maybe my value is too high or too low, and I need to sort of figure out what's going on there. There's another cut. There's a couple cuts in here. So clearly this isn't actually the right value, and I could sort of figure out like what value I need to change to make this happen. or to get more accurate results. Now, also, this is a really crappy quality video. So it's also possible that just because of this like very compressed, very like blurry look, that it's just gonna be hard to find all my crops or all my trims or cuts correctly. But I actually have run this in other places and it's worked fairly well. So your mileage may vary, but it's kind of a fun thing to play with and sort of see how it works. So one note is this sort of this command that was here, spit out all those values to the console. If you want to save those values to a file, come on here. The way to do that is at the very end of your command. This is that exact same command. You do caret to the right, and then you give it a text file. And what this will do is it'll save every one of those values to a text file. And then what you can do is you can read that text file in using Python, and then you can say like, okay, at every one of those points is a starting value, right, using seconds. And then what I want to do is I want to look at the next value and minus a frame, and that should be the entire scene. So that's what this code does. And you'll see I've done the SS at the beginning here, and as well as computed the length. So this should, if I set my value here correctly, this process should split up every single cut or scene in a video and save them all out as individual clips. Now, the reality is this is going to take a while. So if you're doing this with a full movie, I might recommend trimming it down to the first like 10 minutes to make sure it's right before you like set all this up, right? Because if you run this and you just like let it go for like hours on end and it ends up being wrong, you're gonna like feel like you're gonna feel like this is a miserable use of my time. But you can do some cool stuff with this. So like I do a lot of stuff with this, and also in like machine learning process. So I can actually like I've been working on a project recently where I'm taking all these values, and rather than sequencing them the way the film was sequenced, I sequenced them by visual appearance. So I'm actually resequencing the entire film based on like the way like a computer vision system would look at these frames, and resequencing the movie according to that. So there's some really cool stuff you can do with something like this process, but you sort of have to make sure that your value here is right before you do that, because if you don't, like you'll get stuff in weird sequences and whatnot. So I thought I'd just share this because it's kind of fun and you might find value in it, but it requires a lot of sort of like hand manipulation before you really get accurate results. Any questions about that process? All right, so last thing for class, only because I know it's come up a couple times, and I keep putting it off because I just don't know what to do with it, and I still don't know what to do with it, is streaming. So streaming is a really interesting process through Ffmpeg. Like it's very easy to stream through Ffmpeg. It's basically like using OBS. What you need to do is you need to set up your like exactly what you're trying to do. I found this article probably one of the better ones I've read about like sort of live streaming with Ffmpeg. At appearance, I'm actually really interested. I might try. I wasn't able to try this last night, but I might try this with my YouTube account, and just doing a live stream directly from Ffmpeg to YouTube to sort of see how it works. But essentially, all you need to do is set up your where the stream is going, the server path, like the URL key, that sort of thing. And then you can just run a single command to actually stream directly there. Now, the challenge I have here is like just figure out like, okay, why wouldn't I just use OBS if I'm streaming like a particular frame or a particular like file from my desktop? So I think, yeah, it's probably definitely valuable within a streaming server. But I think what I'm really interested in is like, can you actually like use any of the tools or any of the like cool commands that we've been doing while live streaming? And my guess is that you probably can, but it's probably a little annoying, or like you have to think really hard about what you're doing, right? So in the case of like this, you're really only providing a single command, right? You're just saying basically like Ffmpeg, and then like whatever your input value is, which is probably like your desktop or some other thing, and then you've got like a video filter you're using. Now what you could do is I could imagine that you could do something like you could change the hue, right? So hue equals H equals T times 10, right? So this would be every second change the hue value by 10 degrees, right? Like this would work fine because T is like ever going, right? And like you just like could use it for whatever. So like if you just want to have an hour-long live stream where like your hue value just changed over and over again, this should work fine. If you want to get into like VJ world type of stuff, you want to be able to switch things, right? And that's where you get into like, you have to use like that enable filter where it's like enable equals, it would be like enable, what was it? EQ, is that what we were doing? EQ n greater than like, I don't know, say 3600, or sorry, let's say 60, but then also something like, I forget how you combine, I think it's EQ plus EQ, or I guess, and this is all pseudocode, don't quote me on any of this. 120, right? So then this would say is only enable this between the first minute and the second minute. So you could sort of like build up this like long command that you could then like run for an hour. At that point, I think you're probably better off just using other VJ tools, right? But maybe it's a fun exercise. So maybe I'll get to this in the next couple weeks and just sort of see what happens. But it's like you're very limited to what you can actually do, right? Because you've got like this one string, and really all you can say is like, okay, if we're at this value, do this. If we're at this value, do this. I also don't even know if complex filter graph could work through this. So I don't even know if you could do stuff like, you know, doubling or tripling your video and doing things with it. It'd be cool. I mean, maybe there's a whole class here to like try to figure out how to do live Ffmpeg effects and things. I think that could maybe be fun. But it's definitely outside the scope of the next 10 minutes of this class. So yeah, I would definitely read through this article, and if you do get a chance to do some live streaming with Ffmpeg, like let us know what happens. Like I said, I'll probably try one of these YouTube examples and sort of see what happens, because I am really interested in this. Yeah, you could do sine wave, you could do all sorts of fun things with just like these, you know, T filters or T variables essentially. But I don't know what this actually like. I think this runs fairly quickly. I think you could do this a lot like real time, but I can imagine like some of this stuff might start to lag. And I can also imagine like you're streaming and you're using your CPU. It's like some of this stuff feels like it might start to lag very quickly, but maybe it's fun, maybe it's not. I don't know. So I'll just leave with like, here's an article, read it, try it out, and if it works, cool. If it's not, I'll maybe come back to this and try to figure this out. But yeah, it's streaming just feels like one of those things where it's like, man, that sounds like a tough task for Ffmpeg. But then again, I didn't think any of the stuff that we could do today could be possible in Ffmpeg either, but it is. So who knows? Maybe this actually works very well, and we just need to try it and figure it out. Yeah, so that's it for today's class. I've got 20 minutes for questions if anyone has more or wants to try some things out. So just as a recap, I will be sending out, so once this recording is up, I'll link to the recording as well as this, this notebook in the class notes. I will send out a poll for a time to do a show and tell, and also a feedback form for people to give me feedback on the course. But otherwise, I hope you had a lot of fun. I hope you learned something out of this class. I certainly learned a lot out of this class, so that's a good reason for me to teach it, I guess. But I hope, if anything, like you learned that, like, okay, Ffmpeg is understandable once I break it down to pieces. There's a lot I can do with an Ffmpeg, either whether it's purely conversion or whether it's doing more artistic practice type of stuff. And hopefully you'll make something cool out of it. I know I've already seen some cool things from people. And hopefully you'll find that there's a lot of power under the hood once we start to break things down. So with that, I've got about 15 minutes for questions if anyone has any. Well, let me put it this way. Is there anything that I didn't cover in the class that people would have wanted me to cover more of?
I don't think so. I feel like I feel like for me, it's just I'm like, okay, now I kind of understand what I can do. And there's a lot of space for like sitting down and like digging into it more than I'm like, okay, I don't know what this is. Like I went from being like, I can look up Ffmpeg commands on the internet and paste them into things into like, okay, now I actually understand what this is doing. And like the documentation isn't as scary and like I can figure it out and try like these little pieces.
Yeah, cool. That's like, if anything, that's what I want people to get out of this class. That's awesome. I'm glad to hear that. Because yeah, I think likewise, like I've always just for the longest time just sort of copied and pasted stuff and been like, please work, please work, please work. Because if it doesn't, I have no idea what to do. Or I'll like go Google again and just copy in a new command. Yeah, and now it feels like you know, we're starting to figure stuff out. It was even funny, like yesterday as James and I were trying to break down these like trim things, we're like, okay, maybe this is what's happening, or maybe this is what's happening, and we were kind of right. And then we would just miss something like, oh, there's actually an audio file attached to this, you know? So I think even like understanding what's actually happening helps you with debugging things too, which is, you know, with a lot of this stuff is like the key to being able to like actually make this process happen.
Also, I tried making a GIF with the Heckbert filter specifically because it's like, this dithering is broken and we've just included it for reference, and it's literally been taking like the last 10 minutes for Colab to even make it downloadable, even though the same GIF with a Bayer dither took like a couple minutes. I'm very intrigued to find out what will happen by using the forbidden dither.
Yeah, I saw that as the forbidden dither as well, and I've yet to try it, but I do think it's on my list, so let us know how it goes. Oh, I can, you know, really quickly, like, I also said that I would share this, and I will share this with y'all. I have a file that is just like, it's basically all the notes for this class. Very poorly documented, but I'll share this with everyone because there might be a couple things that are in here that I didn't cover in class. This is just literally like all of my like individual like little pieces of code. So I'll share this with everyone in case it helps. I think we covered pretty much, we probably covered 90% of the stuff that's in this thing, but I'll probably add to it. So for example, like there's a crossfade. So if you're interested in like crossfading two videos, there is like a crossfade documentation step. I found this yesterday, which is like one of the most common things that I do for some of my machine learning stuff is all I do is I take an image and I zoom into that image, and then that gets fed through a machine learning process. And I found that there is a zoom pan command that will do that for you directly in Ffmpeg. So I never really have to open After Effects again, which makes me feel great. So I'll share this with everyone. I'll probably just keep adding to it. So if anyone wants these notes, like you can have them. But yeah, it's the other thing that's like crazy about Ffmpeg, right, is like no one wants to memorize what all these things are. So you have to just sort of keep notes somewhere. So again, this is kind of why I like Colab notebooks, because it's a thing in the cloud that you can always access again. And it's like you can add notes and documentation links to it. So yeah, I'll keep adding to this. I did also find, like, one of the other things that I try to think about is like, how can I use this for, like, I do a lot of tutorials where like I'm recording from my basement, which has like a whole GPU stack like right to my right. So all of my videos are very noisy because there's just fans blowing constantly, and there's a noise reduction filter. So I might just also try to run like a noise reduction filter on my videos before I upload them to YouTube, because, you know, my other option would be to open it in like Premiere and run the noise filter reduction, which then takes 10 minutes, and then re-rendering it out takes another 30. It's like, how do I make this stuff faster? And I think that's what Ffmpeg can do really well. So I, for every reason, don't have the code in this cell, but I'll add it back in. So I'll share this with everyone, and you're welcome to like have it, play with it, download it, edit it, do whatever you want to with it. Because yeah, I think there's a ton here, and I think there's a lot more to be played with. So yeah, I'll keep adding to this and just share it with people as well. Cool. So if there are no more questions, I think we can call it a day with 10 more minutes to go. Again, I hope people enjoyed this class. I really enjoyed teaching it. I learned a lot from it. I learned a lot from y'all about what you're interested in working on. And I hope, you know, one, please continue to use the Slack channel. We will continue to have co-working sessions for the next couple weeks, just because I dropped the ball on those, and I want to make sure that we get some opportunities to do more one-on-one stuff with each other about projects we're working on. And then hopefully people can attend the show and tell. So we'll send out a poll for that. So hopefully we can sign up and do that, because it is sort of a fun project, and we usually just live stream it to YouTube so people can sort of watch it that way. Yeah. So once again, thanks everybody, and I hope you have a
Derek.
good rest of your week.
Awesome.
Yeah.
Thanks.
Cool. All right. Bye
Bye.
everybody.
Thanks. Bye.